Okay, so this ties in perfectly with the revision you were doing because you did limits in functions. So we're going to have a little look at a limit of a sequence. So for example, the limit as n goes to infinity of Tn. Okay, so as n gets increasingly bigger, or as n tends to infinity, we're trying to get the limit of that sequence. Okay, so you'll remember a sequence, your general term is called Tn of your sequence. Okay, so you're just trying to see what will the sequence eventually end up at. That's what the limit is. Okay, so we could call that L, the limit of Tn as n tends to infinity or as n goes to infinity. Now there was a few things that we learnt using limits. So the limit as n goes to infinity of 1 over n. Can you remember what that is? So basically, if we pick a number 1 over 10 instead of n, so in this case that's 0.1. What about 1 over 100? That's 0.01. Okay, 1 over 1,000. As the bottom number is getting bigger, my answer is getting smaller. So the limit of 1 over n, as n gets bigger, this is getting closer and closer to 0. Okay, so the limit of 1 over n as n tends to infinity is 0. So that's something really important. Okay, that's the same for anything over n. Okay, as long as the number you're dividing underneath is getting bigger and bigger, it's getting closer to infinity, then this number is getting closer to 0. Your limit is 0. Okay, it might never reach 0, but it will get really, really close to 0. And just something else to note, it's the same for 1 over n squared, n cubed. Okay, the limit as n goes to infinity of 1 over n squared, or k over n squared, is 0. Okay, now I just have to admit someone. Is that alright? Have you any issues with that? Okay, so now if you're asked to get the limit as n goes to infinity, and for sequences and series we're really only interested in n goes to infinity, okay, of two different general terms. So the limit of Tn plus Rn, all you're going to do is you're going to get the limit separately. Okay, so the limit of Tn, and you're going to add on the limit of Rn. Okay, same if you're asked to get the limit as n goes to infinity of a product of two different general terms. You're just going to multiply the two products of the limits separately. So get the limit and get the limit of Rn, and you'll just multiply your two answers. Okay, so the limit of a sum is the sum of the limits. Okay, and the limit of a product is the product of the limits. So you're just getting the limits separately and multiplying them here, getting them separately and adding them here. Okay, and same if you're dividing. Okay, you're just going to get the limit as n goes to infinity of Tn and divide it by your answer for the limit as n goes to infinity of Rn. Okay, so we might just have a little look at doing some limits. So example 1, if you're finished taking that down. Can I get rid of this? Okay. So, I'm wondering if you can remember how to get the limit as n goes to infinity of something like this.
Put everything over n squared.
Lovely, exactly. Put everything, divide everything by the highest power of n that you have on the page. Okay, lovely. So that is going to be the limit as n goes to infinity. We're going to divide everything there by n squared, and on the bottom everything by n squared. As long as I divide the top and the bottom by the same thing, I'm not actually changing my sum at all, so that's why I'm allowed to do that. Okay, so my n squared and my n squared there cancel, so I'm left with the limit as n goes to infinity. On top I'm left with 3. On the bottom this cancels, and n squared divided by n squared is 1 plus 5 over n squared. Now, what is the limit as n goes to infinity of 5 over n squared?
Zero.
Yeah, exactly. Okay, so here we have, I'm getting the limit now. Okay, so it's 3 over 1 plus, and we know this part here is 0. Okay, anything over n squared, anything over n cubed, as long as you're getting the limit as n goes to infinity, your answer is 0. So I end up with 3 over 1, which is just 3. So my limit of this general term is 3. Okay, so the numbers will tend towards 3. Okay, let's just have a look at another example there. Okay, so the limit as n tends to infinity of n cubed minus 4n over n squared minus 2. So in this case, what am I going to divide everything by?
N cubed.
Yeah, perfect. Okay, so that's going to be the limit as n goes to infinity of, divide everything you see on the page by the highest power of n. So n cubed there, n cubed there, and n cubed there. Okay, then you're just going to tidy it up a little bit. So n cubed over n cubed is 1. That n and that cubed cancel, and it becomes an n squared on the bottom. So 1 minus 4 over n squared. Over here, n squared and n cubed. So n squared over n cubed, you're left with an n on the bottom. So that's 1 over n. And this is just minus 2 over n cubed. Now, to get the limit of these things, this here is going to be what? 4 over n squared? Come on, talk to me. Thank you. 0 here, 0 here, 0 here. Okay, so the limit is 1 minus 0 over 0 minus 0. Okay, so you end up with 1 over 0.
Miss, why is it 0?
Why is it 0? So that was something we learned at the beginning. Who was that?
Sinead.
Oh, okay. Will I explain it to you in a minute, Sinead?
Yeah.
I'd say you just missed that little bit. Okay, so we have here
You
one.
know, if you know the way the first kind of part you put the n cubed over n cubed
Yes.
separate to the, you know, if you put them both numbers over the n cubed, is that technically wrong, or?
It's not technically wrong, but it's not going to help you. You'll still have to separate them out eventually, because for limits you need to get the limit of each part separately. So remember when I was saying you're getting the sum of two different things, you separate them out and get the limits separately. It's the same thing here. So I know you could put it all over n cubed, but you'll eventually have to put both over n cubed anyway, so you might as well just,
Okay.
yeah, throw n cubed under everything.
Okay.
Okay, So you have 1 over 0 here as your answer, girls, and anything divided by 0 is undefined, okay? So all you're going to write here is undefined, and what that means in the case of limits is there is no limit. That means, girls. Okay? So when it's divided by 0, it's undefined. If you have 0 divided by something, your answer is just 0, that's fine. Okay? But if it's something over 0, you say there's no limit.